thank you all for coming. I'm Bill Squadron. I'm the president of Our Energy Policy, and thanks to all of you for joining us today. This is actually our first in-person event of the new year. I think as we entered the first quarter, we saw how tranquil and uneventful things were. We thought no need to talk about anything. But in all seriousness, as you all know, Our Energy Policy is a nonpartisan organization with really a steadfast commitment to dialogue and to civil conversation about the issues that challenge all of us every day. And I think it almost goes without saying that we need to have that kind of interaction, people really committed to serious, substantive discussion and progress, solutions, creativity to move forward as much as ever. So we are 100% committed to continuing our work. We have a very ambitious schedule going forward. Some of you may have heard our webinar. The recording is posted on wildfires and utilities a couple of weeks ago that I thought was really fascinating to hear from real experts on the issue that has clearly been, unfortunately, a big part of the headlines lately. We have another webinar coming up, which I would highly recommend to you in a couple of weeks on sustainable aviation fuels. We have another event here, which I'm sure you'll hear about at the end of April, on nuclear power. So we have a very ambitious schedule coming up. Our feeling is there really is a need to bring people together, people who don't necessarily always have a chance to engage with each other, differing perspectives, but all hopefully committed in good faith to talking about ways to move forward in a positive way. So thank you again for being here. I do want to thank all of our partners. We couldn't do this without their support. Many of you are here today. Those of you who are not partners, we hope you'll consider joining our partnership program and supporting what we do. And probably myself or Carol and Bess, who you've met, will probably reach out to talk to you about that. But we certainly hope you will consider that, and it will help to sustain the growth that we have been undertaking as an organization to try to reach out and touch more people within the community and advance more solution-oriented discussions. So thanks to all of you for being here. Thanks to all of our partners for their support. To start off the discussion today on battery technology and energy storage, one of our partners and our co-host, Alpha Generation, is represented here by one of my good friends, Senior Vice President for Regulatory Affairs, Liam Baker. He is responsible for government policy, commercial matters for Alpha Gen's 14,000 megawatts across multiple states. He's both an engineer and a lawyer, so he brings real expertise to this issue. And it's my pleasure to welcome up. He's going to give us some opening remarks, and then we're going to move on to our panel. Liam?
I'm not supposed to tell them I'm a lawyer, Bill. People like engineers much better. Thank you very much for the introduction, and thank you to OEP for standing up this really important conversation. As Bill mentioned, I'm here on behalf of Alpha Generation. The joke I use is we're the biggest power company you never heard of. We own about 14,000 megawatts of thermal generation. We're the largest owner-operator of power plants in New York, New Jersey, and Connecticut, including 5,000 megawatts here in New York State, including 6 sites. We are big believers in battery storage, and we do believe that it is an important part of a transition away from resources like our own. And as the owner-operator of a large fleet, particularly a lot of retiring peaking plants, everyone's heard about the peaking plants and the challenges they face, and we are preparing to retire many of those, but there's an opportunity to transition some of those sites into locations for new large-scale batteries. Some of the advantages these older sites bring are site control. We all know that industrial real property, particularly outside of EJ communities, is tough to come by, and in metropolitan areas, particularly New York City. We also have a large existing interconnection infrastructure for our existing facilities, and we leverage that by reutilizing existing interconnections to facilitate more rapid onboarding of new battery deployment. And lastly, an important thing that we are working with our partner Elevate, I'll introduce Seb in a second, is co-location. So if we have facilities that are slated for retirement, one thing we're working with our ISOs is co-locating brand new batteries behind a common point of interconnection. So as the older facility runs less or even retires, that new battery facility can utilize that old interconnection without unnecessarily building out a whole new substation, facilitating a more quick deployment. We are owned by ArcLight Capital Partners, a large private equity firm. They also own Elevate Renewables. They stood up Elevate Renewables to work with us to explore opportunities to deploy utility-scale batteries at all of our locations. And Seb will be speaking on their behalf on the panel. And just so you know, we do put our money where our mouth is. Just 2 weeks ago, we submitted over 200 megawatts of applications for new batteries at our existing locations here in New York City. We're hoping that if anyone from Con Edison is in and they want to, that RFP, thank you. Okay, appreciate it. Yeah, good. We'll talk later. But the whole concept here is to repurpose those sites, and as these older facilities retire, they are still going to need it for reliability, but the faster they can be repurposed with dispatchable batteries, the faster they can go away. So with that, looking forward to today's discussion, and thank you, Bill, for the introduction, and let's go. So, thank you.
Thanks, Liam. Somebody just asked me if this is wine. No, things are crazy, but no, this is Diet Coke. Yeah. I may need wine, but I'd now like to ask our panel to join me up here. So I see where you all seated. Come on up. One thing we always do is at the end of the conversation, open it up to questions from the audience. So if you all have questions, please, note them, and we'll definitely get to them as much as we can toward the end. I also want to acknowledge two of our board members here, Bob Cattell and Stephen Birkenfeld. Thanks, Bob and Stephen, for the great work that you all have done in support of the organization. All right, so let's get on to the conversation. We have a phenomenal panel of experts here. Our moderator, Lauren Marbella, is an associate professor of chemical and engineering at Columbia. She is the head of a research team that looks at electrochemical performance associated with chemistry, interfacial chemistry in devices for electricity storage. She is truly I was going to say genius, but truly an expert in this field, and she's going to moderate this discussion, and I'll let her introduce our panel. Lauren?
Thank you for the very kind introduction. I'm happy to be here today, and it's my pleasure to introduce our panel. So today we have David Sandbank. David is the Vice President for Distributed Energy and Energy Resources and Clean Transportation at NYSERDA. David leads a team of 45 professionals managing $5 billion across programs in distributed solar, energy storage, and clean transportation. David? Thank you. We also have MJ Shiao. He is the Vice President of Supply Chain and Manufacturing for the American Clean Power Association. There, he leads initiatives to enable resilient supply chains and domestic manufacturing that support the sustained growth of the U.S. clean energy industry. And last but not least, we have Sebastian Engelhart. Sebastian is the Senior Director of Strategy and Business Development at Elevate, where he is responsible for the platform's growth strategy and evaluation of capital deployment and risk management at a project, portfolio, and corporate level. So we're going to start off by just having a chat up here. I'm going to ask the panelists a few questions. We're going to have a discussion, and then we'll close out the last 20 minutes taking questions from the audience. So just to orient everyone, make sure we're all on the same page, I just wanted to start off by gauging everyone and talking a little bit about the key differences between the battery storage that we use in our mobile devices, in our computers, and those that we're using in micromobility, so things like e-bikes that we see all over the streets of New York City, electric vehicles, and grid storage. So David, maybe you could start us off.
Sure. I remember when micromobility was causing mayhem here in New York City, and it probably still is, and there's reason for concern there. We're talking about e-bikes and scooters. There's 64,000 food delivery service people in New York City alone. And a lot of them, don't get paid very well, and they're 1099 employees. And they buy and purchase batteries from Amazon and online that might not be compatible, nor are they UL certified for the bikes they're using. And then they don't have the charging opportunity to be able to charge them safely, and they put them on power strips with multiple chargers that are not UL certified. And it's just a recipe for disaster, as we all have witnessed. And so I would call it an unregulated market, whereas energy storage is highly regulated, obviously, with UL 9540, UL 9540A testing from UL. In FDNY is the most sophisticated authority having jurisdiction in the country when it comes to energy storage, and that really paid off for us, because now you're going to see most of the development of standalone storage really happen mostly in the 5 boroughs, because they really know what they're doing for many reasons, which I can get into later. But big difference between the two. They're both primarily lithium ion, but there is safe lithium ion, and there's less safe lithium ion depending on the battery management system, and also whether it's regulated or not industry.
Yeah, I think that's a great rundown, and I just add that the fundamental technology is similar, but certainly the engineering that goes into something for micromobility or even just electric vehicles versus grid energy storage battery is going to be different. It's going to be optimized for the application. And so even when we look at something for electric vehicles, you tend to have things that are going to be favoring higher energy density. You're trying to pack a lot more of that storage into a smaller volume, whereas on the grid storage side, you don't have as many space constraints, and you're looking more at longevity and cycle times and wanting these assets to be out there for a decade or longer. Versus a vehicle where you may be able to service, right? So there's going to be differences in technology, and I think that's one of the things that's important as we think about how the technology develops as well. First of all, that these batteries aren't going to be interchangeable necessarily, and nor do we necessarily want them to be, and that's going to have an impact on certainly how we think about the supply chains and how also interchangeable manufacturing something for, again, an EV application versus like an energy storage application would be. But fundamental technology is the same, but very different when you see it in the real space.
For the sake of open conversation, do you mind if I just build upon what he says?
Sure.
Yeah.
Because when you talked about technology and chemistry, I think it's really important for everyone to understand that although these are all mostly primarily lithium ion, pardon me, there are 800,000 Powerwalls deployed in the world with one incident, right? There's EVs have a much, much lower risk of catching on fire than an internal combustion engine right now, but yet they're using lithium ion. So it's how it's standardized, it's how it's procured, it's how it's built, and it's how it's regulated, which in my opinion is much more important than the actual technology itself.
Yeah, I was actually going to build on that. So, the energy storage industry today obviously has built upon the EV industry and has been able to benefit a lot from it, particularly on the lithium ion side. But we've made a lot of leaps and strides since then, and continue to see the energy storage industry stand up on its own with pretty unique attributes that are different than than an EV system. And so some of the early safety events that we've seen in the space, were based on systems that look very different than the systems do today. And we've come a long way in terms of containerizing the layering on top the energy management and battery management systems of how these actually get controlled and monitored, and actually how we comply with the various testing requirements and safety requirements. So the industry's like really, really matured a lot and starting to be full-fledged on its own.
So let's dig in a little bit more there. We have all of these applications, we have the same chemistry, and then we have what seems to be a difference in quality control, maybe pack safety that you're putting in, and then differences in the battery management system within those inherent applications. And then as we sort of scale up, it seems like there are less incidents, but we still do have some serious incidents. I think, when we were talking about putting this panel together, we talked a little bit about lost landing and things like that. So can we maybe just touch on these things and where some of these differences come in on a technological side?
Go ahead, sorry.
Sure. Yeah, happy to. So when we look at a system like Mars Landing as an example, this was built as inside of an old power plant with open air racks where the batteries were all back to back to back next to each other, and then stacked on top of each other, right? And on two different container floors, and they were using a NMC chemistry. As we look at the systems today, these are all containerized, where they are created, not customized to a particular factory, to a particular site, but created in factory and on a common spec and based on an LFP chemistry largely today. There's still some NMC being used, and then just on top of that, the various testing that we go through now, and I think David will probably layer in more detail there, has come a long way in terms of the standards that we're actually complying with.
Yeah, and actually to build on that too, I think it's important just to contextualize the safety as well. David talked about the power walls out there. At American Clean Power, we've tracked I think around 23 fire-related battery storage events over the last decade, right? And in that period of time, we've seen a 250x growth in the amount of battery energy storage on the grid that's being deployed. So, in comparison to a lot of other technologies, these systems generally are relatively safe. Now, of course, one fire-related event is far too many. There are a lot of unique circumstances with Moss Landing specifically, but it's not enough, obviously, as an industry to just say, oh, well, that one was just kind of its own thing. I think we've done a lot of work as an industry to really work with NFP and really champion on NFP 855, which is storage safety standard, and working with a number of states to try to get that implemented as a standard as well. And I know New York is doing a lot of work on this, which maybe David, you want to touch on, but I know it's been a very thoughtful process for the state too.
Yeah, thanks, MJ. It seems to be the majority of the work I'm doing these days is fire safety with energy storage. Why I was up really early this morning, but it's interesting because us in the room could say, yes, when you look at the amount of deployment, there really is a small percentage of batteries catching on fire, but the public's not going to hear that. That's not the message we need to deliver. And I think what Governor Hochul did, which is right, was saying, time out, right? Like, we had 3 incidents in the state of New York. We don't know how, we don't know why, but let's put together a interagency fire safety working group to figure out why, what happened. So I could speak a little to that, which is we had to, number one, we detailed and worked with DEC to look through the air, soil, and water contamination levels. And we discovered that looking through all of the indicators that there was no levels above what was concerning at all on all 3 projects. So check, that was good. Next, we're working with the 3 projects to get the root cause analysis from all projects. I don't think I'm going to get them from all 3. I'm trying really hard. I got a commitment from 2 of the 3 projects right now, and we have a root cause analysis from 1 of them. We're going to be releasing emergency response summary, which will include the root cause analysis for the Warwick project in the near future. We also inspected every project that was 600 kilowatts or greater in the state of New York, and that was 57 projects. And I have a summary report that's going to come out momentarily on the near future on that and lessons learned. And then I think you all might have heard that we also have 15 code recommendations for the Code Council to consider that we expect are going to be in code intact by the end of this year. So we've got a lot done. Lastly, on May 7th, this is the first anyone's hearing about it publicly, the Fire Safety Working Group is going to conduct a webinar to all authorities having jurisdiction and all towns and municipalities in the state, public webinar on how to deploy safe lithium-ion storage in your community. And so that we're going to get out there because of all the moratoriums popping up and everybody just going on hold because they want to wait until the new 2025 codes come.
Yep. I think the last piece I'd just add is, I think as an industry as well, we've trying to be more responsible about the siting of where we actually put these batteries, and intentional about making sure we're not locating them right in the middle of residential neighborhoods, that there's appropriate setbacks away from other sensitive uses, and that they're in the right places for the use case, which is electrical infrastructure, right? And so as Liam mentioned, we're doing a lot of work today looking at trying to put batteries on site around existing power plants with a co-location strategy, but want to make sure, as we look at other battery system deployments around the country, that they're in the right place to also just be the appropriate use for the communities they're in.
It's a really good point because location really matters. Fawad, you know that firsthand for your project. But it really matters. And in Staten Island, they're so adamantly against energy storage, but they have 3 different zoning districts, right? There's manufacturer, there's commercial, and there's residential. And when I look through all of our projects, very few are in residential districts. However, the manufacturing districts out there, they have homes right near some of these projects, and it's causing an uproar. So location really matters, and I get it,
And I think that's something we'll keep coming back to in some of my later questions is like location and how it makes sense for a lot of these things, especially like critical minerals and whatnot, but we'll get there. So I think another important point that we touched on there is that, how we've been able to optimize these technologies is really amazing. And as we scale lithium-ion batteries, even if the percentage of incidents continues to go down, 1 incident is still going to be too many. But we have lots of other really exciting technologies upon us as well, things like machine learning and artificial intelligence. And I think these can also start to solve problems a lot faster than any of us can with all of the problem-solving tools we even have at our disposal. So maybe we can just talk a little bit about how machine learning, AI, large language models are helping address some of these problems that we have with safety, but not just safety, how we are running these storage systems more efficiently whenever we're interfacing with the grid and things of this nature, and how we actually balance that. So like, how are we detecting pack health versus peak demand and things of this nature?
Do you guys want to take it?
Sure. I mean, I can start, which I think, folks that have been looking at the energy storage industry for, really any amount of time has seen a ton of innovation, just, that's even last year or even looking in the past decade. I think, tremendous, improvements in terms of, power density and efficiency of the systems overall. And then I think as we think about how to operate these systems more safely and more efficiently as well is really centered around the, the communications, the control, the intelligence that goes behind that. And that has a number of applications. You've already touched on some of them, where if you're looking at an energy management system or a battery management system, it's spitting out a ton of data, and a human can look through that and try to figure it out, or you can have little alerts here and there, but at a certain point, it just gets overwhelming, right? The number of systems that are deployed, when you start to think about each system has multiple battery modules, each of them has multiple battery cells. So AI is going to be incredibly important in taking all of this operational data that we've had as an industry, putting that in, and then allowing us to look at and really assess what the current health of the system and even the individual cells are. I was talking to a third-party analytical firm not too long ago who, this was a real situation that they had actually in Europe, where some provider had given them a lot of data just to trial, wanted to see what analysis they could come up with. And they started looking through it, and their team's like, hey, I think there's actually a real problem in this. And it turns out they had found that one of the cells in a electric bus in Europe that was actually running at that moment was on the verge of having an issue and could potentially cause a thermal event.
Can you not say that, please?
But they found it. They found the situation, right? They used this analysis to identify it, to make sure that that bus was looked at, retired safely. And so that's the opportunity, right? And it's going to be increasingly important for developers, for people that deploy this technology to look at and properly use those tools.
And I think this is so interesting in the sense, can we get good enough to see these events before they happen? Because being able to do this is so difficult with it, but whenever you have all these data streams, it really does become possible with things like artificial intelligence, where in other cases it might result in a safety event. And you can also do this when, I know in Europe you have a battery passport, but in the United States we don't really have a system like this. So if you're going to be using an old battery, do we have machine learning tools where we can take a battery that's been used before and then just start using it and actually understand, is this thing healthy or not? And those things would be really helpful. But anyway, carry on.
I think the broader topic too is just central station monitoring, because AI is going to be in everything we do, and storage is certainly going to be no stranger to that, right? It's going to optimize a lot of our things we do in the economy. And I'm no expert by any stretch of the imagination, and don't nearly know as much as you guys, but I was curious about machine learning and AI and how could that de-risk projects. So I had the opportunity to talk to two developers that have very sophisticated central stations and monitoring, Tesla and Xterra, and I learned a lot by talking to them. And there is a lot being done. There's 2,200 or so data points you get in a second or something with storage, right? But what good are those data points if you can't keep up with them? And that's the issue. And on the average, a storage project could get about 100 alerts a day, right? And the certificate of fitness holder has to look at those and say, what's alarming, what isn't alarming? Tesla might look at it if they're the OEM and say, okay, this is one where we need to drive a truck to, or this is one that's going to go straight to the fire department because it's an actual thermal runaway incident. So I think because it's so data heavy, not only on fire safety, but optimization, degradation, the financial aspect of optimizing it, that it's just going to affect everything we do in life, including energy storage.
Yeah, I would add sort of outside of the BMS, EMS, operating data set, there's sort of two other quite interesting ways that machine learning AI systems are actually driving improvements in the way we think about battery storage as well. So one is again on the siting side. The biggest challenge that a lot of developers are facing today with trying to look at deploying new batteries is understanding, we have a grid and a transmission system that is extremely constrained. And the biggest limitation is often how do you get a project through the interconnection process to have a LGIA in hand and with, that's sited in a place that doesn't have exorbitant costs to upgrade the grid around it, right? So how do you smartly site your project And there's a lot of new tools coming out that are helping developers do that, adding sophistication around being smart about where you can actually target looking at siting these projects. Then the second piece is just around battery design, and the manufacturers are also spending a lot of time improving the density through smart pack design and optimization, and then both at the cell level and then the configuration level of once you put multiple cells together inside of a container, how do you get these into this container in a way that's optimized for safety and density, and so they're able to accelerate that curve on density safety improvements quite rapidly as well with some of that technology.
Yeah, and to build on the manufacturing side too, I mean, it plays a huge role in QA/QC as well. As you are in line in the manufacturing process, as these cells are being tested, AI can learn in real time and alert in real time, hey, there might be an issue while we're in the manufacturing process itself, and that stuff just doesn't ever make it into the field, right? So that's part of the safety by design philosophy that a lot of manufacturers are taking with, as they build these battery cells and battery packs too.
That's so fascinating that AI could help de-risk a project in the supply chain before it even gets built.
I mean, that's the ideal place to de-risk.
Good point.
Yeah.
Yeah, so I think there's big opportunities that's going to help us optimize, help us accelerate. So let's talk a little bit about getting these systems online and scaling them. So how are regulations and policies going to impact the development and deployment of battery storage technologies, let's say in the next 5 to 10 years or so? Maybe in the next year.
I can start on I spend most of my day on the federal policy side. So clearly, I think the most important milestone for energy storage in the past few years has been the passage of the standalone battery investment tax credit, right? Previously, these storage systems had to be attached to solar to really take advantage of the investment tax credit, and now we can have standalone systems that qualify all by themselves, and that has made the economics for deploying storage, that has made we're able to now do it in much greater scales and across a much broader swath of the nation. So that clearly is going to be, I think, one of the most important things as we see the battery storage market going forward in the U.S. is what is the fate of those tax credits, certainly with everything that's happening in Congress, and that will have an impact, I think, on also the states that have these targets for deploying storage or have these incentives for deploying storage as well. And certainly the federal government is helping to bolster the economics that takes a little bit of the weight off the states, and what do they need to do to support these targets as well. And then secondly, part of that deployment too is the supply chain that comes behind it, and part of that same package was the advanced manufacturing tax credits, or folks refer to as 45X, which allows us to also start to build the battery cells, battery modules, hopefully further upstream to critical minerals and anodes, electrolytes, cathodes, all in the U.S. as well. It'll take time to get there, of course, but that becomes a more fulsome industry, and I think those are all going to be important, as we kind of, face into a lot of the trade uncertainty that we're seeing certainly this year. But even regardless of the administration, certainly a lot of geopolitical maneuvering that's happening regardless. That's going to also having us have a more resilient, a more domestic supply chain is going to help ensure that the energy storage industry can continue to have the supply chain it needs to continue deployments too.
Yeah, I'd say building on that, around the manufacturing piece, that is, it will take time, but we're seeing stuff that's happening near term and actionable in the next 12 months here, right? So multiple different battery suppliers are standing up facilities where they're manufacturing today in the US, the battery system, and a number of them are aiming to have cell manufacturing happening in the US as well by the end of next year, 2026. So actively being set up, we ideally are going further up the supply chain to the various component parts, but seeing some interesting development of local lithium production as well in mining, and various attempts there, which is extremely valuable, and the advanced manufacturing credit has helped a lot with that, right? I'd say as we look at deployment and from a developer's perspective, we really look at the benefits at the federal, state, and local level, and the IRA drives a lot of that. At the state level, the reality is, depending on where you are in the U.S., batteries don't necessarily make sense on their own in a sort of just operating in the market today, and so part of that is sort of related to the attributes that a battery brings aren't necessarily captured cleanly in what you can sell into a ISO market, right? That capacity and ancillary services and energy are only going to capture so many quantifiable benefits but there are others that batteries do provide, and so that's where we look to the states or to the utilities, to provide further support there, right? And so NYSERDA has been doing a lot of work at various levels on the index storage credit, which is coming out hopefully this year at the utility scale level, but VITA and some of the other local behind the meter incentive programs are also extremely beneficial towards helping get these battery projects online and supporting a project that makes sense to be economical and financeable. And I think as we look at it, a lot of the challenge isn't necessarily just providing money. Sometimes, for us, it's actually just providing certainty of the money, and that's part of how the index storage credit is intended to function here, is providing effectively saying we're going to swap out what is an uncertain revenue stream when you participate as a resource in NYSO with a more certain revenue stream that's relatively similar in value. There's a little bit of an adder, but the biggest benefit you're getting here is then we can take that and go to our project finance tax equity partners and say, look, we have some certainty here on what the revenue is going to be, and that really helps with getting these projects financed and done. The last piece I do want to just highlight is on the local level, that I think it also how we engage with policy at the local level around makes a big difference, and so being proactive with engaging with various host communities around these. We talk a lot with various communities about host community agreements or pilot programs, payment in lieu of taxes to provide revenue and value to the community, and make sure that we're working hand in hand with fire departments, with the local community around getting these sited properly, and then making sure that everyone's on board to support the project.
Yeah, I think on the should I?
Yeah, go for it.
On the policy side and regulation side, I would add codes to that too. You two talked about federal and finances and stuff like that. I think what I really learned the most, I'll cover it from like a state perspective, is standardization is really the most important thing we need to do. The majority of fires the majority issue that cause the fires are usually the BMS, the system around the battery, not always the cell itself, the origination of the fire. And I think that's where we're really focusing, because I can't really control like LG Chem cells very well, but I can control our requirements and rules and regulations and codes around that and how it's deployed. And when a lot of our lessons learned with the Fire Safety Working Group, really the result of that is these 15 code recommendations. And what we quickly learned immediately was, in looking at all these different the 3 incidents as well as all the projects, in the current code, it allows the local authority having jurisdiction to do a peer review, and they could require that if they ask for it. Now, this isn't their fault. Outside of FDNY, there really aren't many authorities having jurisdiction that have the ability to look at a peer review and say, and decipher whether or not they feel this is good for their community or not. Can give you an example, like there are people who look at a 9540A testing as a pass-fail result, and they say, great, you did that, and that peer review could say, the UL lab decided to test it, and we couldn't test it because of fear of explosion, and yet they could deploy the project anyway because they don't know enough to look at it. So what we did is we say mandatory peer reviews in the code, new code language, as well as any project now that comes through NYSERDA has 3 critical components within that code prior to it being adopted. One is mandatory peer review. We've got 3 nationally renowned companies that are going to do those peer reviews, and we're not going to incentivize that until we're happy with the peer review. 2, we're going to follow up that with a field inspection to follow through on, was it built to the spec at which that peer review said it would be designed to be built. 2, they have to prove that they're training the first responders and have continued training. 3, it has to have an emergency response plan. 3 basic things that I think could dramatically affect de-risking the fire safety issues that we've seen here in New York. So to me, it's what can we do? It's all about standardization. I go back to, there's a lot of people who have cell phones in their pockets right now. You're not fearing they're going to catch on fire. And they've been around for a while. It's how things are built, right? And these standalone energy storage projects, they're all snowflakes right now. They're all built differently by different crews that procure different materials. And they have different meanings and different use cases. So we need to standardize the industry more.
Yeah. Agreed on all points. So we talked a little bit within that conversation about the cost as well as what's going into the battery. And MJ, I believe, brought up some critical minerals, and I'd like to touch on that again. How does both the domestic and global supply chain for critical minerals, so things like lithium, cobalt, nickel, copper, how are these all going to impact the development of new battery technologies? What are some of the sustainability challenges that we have? And can we maybe talk a little bit about recycling efforts around that? Because that's really going to ramp up within the next 15 to 20 years as well.
I can start again. I mean, I think if we look at the global supply chain, I think, as Sebastian mentioned, we are starting to see more of a domestic manufacturing industry for energy storage, especially for EV applications and increasingly for grid storage applications emerge. A lot of that has been more downstream products, integrated systems, battery management systems, modules. We'll start to see more and more cell manufacturing in the U.S. as well. But it takes time, of course, to onshore and develop a supply chain, right? The folks that are making the cathodes need to know that there are viable cell suppliers in the U.S. in order to feel like they can comfortably stand up manufacturing here. And so what we have as a result currently is that there is the battery supply chain, especially when you look at critical mineral processing. There's one dominant player. It's China, right? To no one's surprise, and they've simply just have been investing in this industry for a lot longer, and for in its nascency, and continue to invest in it as a part of their country's policy, and that has allowed them to take the lead on the technology. Now, I don't think that lead is insurmountable. We are still very much in the early days of battery storage deployments. But it does require us as a country to look and see, well, if over 90% of our graphite in the world is being made in China, what are we doing just as a matter of practical, sensible procurement practices to diversify where that material is being sourced from? And so I think that's one of the bigger opportunities. One of the things that we have to capture as a country is how do we look at some of these upstream technologies, upstream materials, and seek ways to partner with our allies, as well as encourage more domestic supply and manufacturing of it as well.
Do we have any allies left? I haven't checked today.
Yeah, one thing I would add here is, 2 years ago, there was a big spike in the cost of lithium that caused huge havoc in our industry. Contracts were canceled, projects were wholesale tanked, and companies went underwater. The cost of lithium went up 4x versus where it sits today and where it was sitting before. I think, and you've probably spent a lot more time looking at this, but our understanding is that the industry has responded, and there's a lot greater build out of lithium mining, processing, and transformation into material that's ready for the cell. I think we're seeing that a lot of other elements of the mining processing supply chain are also responding globally, and there is a build out across other rare earth minerals. This still remains a key focus and concern. But sort of beyond the minerals component, there are other supply chain challenges we definitely still are dealing with, and that are very real and painful for getting these projects online. So, two big ones that come to mind are at the substation level, when we look at the high voltage equipment that's required, so transformers and breakers primarily. These now, to get this HV equipment built, you need a sort of 24-month lead time between when you place an order with one of the 3 limited manufacturers of these, and when they will actually show up and deliver these on site. So both developers and utilities are dealing with this pain, and as you think about needing to upgrade the grid, and a lot of the tension and the lag between when a project might be ready to be built and when it can actually be built and online is associated with this bottleneck around the transformer equipment taking a long time to place, secure a slot and then bring it into the U.S. after manufacturing. So that's one piece on supply chain, and then I think the other piece is just around the uncertainty with respect to importing, right? And I think people are living this live day by day here at the moment, but developers are spending a lot of time at the moment focused on ways we can mitigate and diversify the supply chain strategy, and looking at ways to safe harbor, to sort of lock in various tax benefits, and then onshore and warehouse product in the country earlier, so to sort of insulate around tariff risk, right? So that's definitely of high focus today. I'd say the mineral side is probably a little less so than it was 2 years ago when it was driving our system prices up 30-40%.
I have a personal question about this critical mineral thing, which is that, when opening a new mine for any type of critical mineral, you take all this time to survey, to permit, to open, operate, and then have a plan to close down at the end. But when we start thinking about battery recycling, does it make sense for our communities and all that effort to start to co-localize things? Because when you're mining something, you have a mineral that has a very low percentage of these critical minerals, but then you have a battery coming in potentially that has a much higher percentage. And in principle, you have a facility that is optimized to do it, and there's no one better outfitted. So is this a route forward that we could see in the next 15 years when we have all these batteries on hand?
I think it's something that we have to start investing in now. I mean, if we look at the scales today, we are installing more and more batteries on the grid. However, these assets should be running for a decade, if not longer, right? So, just because, there's sort of a lag between the amount of deployments we have and the opportunity to actually recycle them and re-extract the critical materials from them. That being said, there certainly is recycling being done. A lot of it is focused more towards EV batteries, just because that's where the volume is, and certainly higher volumes, and more concentration of it, some of the materials as well. And again, it has to be part of the long-term plan. But I do think that 10 to 15 year window is sort of the right one to think about as to when we start to see this emerge more as a even a significant part of the material supply for battery supply chains.
Yeah, and recycling is mining, right?
Exactly.
Because I think that's the way to say it. Because if you think about it, every time we import something, its second generation is going to be domestic content, right? And I think that's really key. And you have a 10, 12 year window where it gets its lifespan exists. So I think it's really important we understand that this is reusable in a sense.
Yeah.
And maybe it makes sense to not shut down a mine in the future, and then you sort of eliminate this phenomena where we've had in the past of a coal town that sort of becomes this ghost town, and that just doesn't happen anymore. I don't know. Sebastian, sorry.
No, I was just going to say that, as we think about new battery systems coming online, a lot of the time, we work together to be smart around what is the end of life plan around this. So what is the decommissioning plan? And so making sure that as we build those decommissioning plans out, there's also responsible recycling plans baked into those, so that we don't just scrap the system, that we do keep and retain the appropriate minerals and various parts for reuse is important.
Yeah, I got to start thinking about it. My EV has about 120,000 miles on it now, so I'll let you all know what happens.
All right, so I'm going to ask the panel one more question before I turn it over to the audience, which is just a forward-thinking question. Looking ahead, what do you think is going to be the big game-changing innovation that could revolutionize energy storage industries in the next 5 years?
Sure. Yeah. My contrarian stance here is we're less focused on revolution and more on incremental improvement and deployment. That we have a lot of different tools in the toolkit of as we move through this transition, different technology we can use that exists today, and there are various technologies that need to scale and just improve on cost and safety. But by and large, we're in the mode now of how do we figure out how to put these things onto the grid and drive as much benefit there as possible. So we'll continue to see energy density improvements, improvements in layout and safety that that are going to be interesting, and maybe we figure out and get comfortable around various ways to stack batteries to drive greater density. We tinker on chemistry. Sodium ion is getting a lot of attention at the moment, and it's going to be interesting in certain uses. Flow batteries will probably continue to have a small and focused use case. But really, we sort of need to be in the mindset of how do we deploy these in the right way to scale.
I knew I should have gone first on that because that was going to be similar to my answer. I think there's a lot of
three of us.
right? I think there's a lot of exciting things in the hopper, and sort of folks thinking about next gen batteries. Sodium ion does seem like certainly one that's almost ready for commercialization. But I was looking actually this morning at some Bloomberg NEF analysis that where they were projecting what is the chemistry mix going forward in the next 5-10 years, and 5-10 years out, it's still predicted to be lithium iron phosphate, right? It's the same technology, same chemistry we're using right now. The share goes down a little bit, but it's still very much the dominant. Now, it's always tough to predict the future, right? And these technologies can change, and if there is something that can hit the same economics, can deliver better safety performance, all of that, we might see a rapid shift. But I do think right now a lot of it is, as we get closer to economics and market designs that work and allow energy storage to really show all the benefits that they can deliver to the grid, that is what's really going to drive deployment versus the magic silver bullet technology.
And just to make it quick so we can get to the Q&A, I'll just say it's not revolution, it's evolution, much like you're saying.
All right, so We'll take some questions from the audience now. I think the first hand up was back there. I don't think we have a mic, so please just stand up and ask your question.
Obviously, you talked a lot about battery storage, but just curious about your view on other energy storage, hydrogen, compressed air, steam, gravity-fed systems. I'm sure there's a place for all of those in the future of storage. Maybe you can speak to that.
Yeah, so I mean, I'd say that absolutely is a place. We today get a lot of value out of hydro as a resource on the capacity side. Frankly, we get a lot of value out of existing gas and fossil plants on the capacity side, and those, in many instances, will continue to play a role as well. I think as we look at the suite of various tools out there, the challenge with a lot of the various technologies you mentioned is repeatability and deployment agnostic to location, right? That, cavern compressed air, for instance, you're focused on where do these sites exist today. Same thing with hydro. So I think there's interesting other technologies that can be deployed. As we've sort of looked at it, the benefits of round trip efficiency on the energy as you cycle it, and the benefits on the cost side of a lithium-based energy storage system just outweigh, in most instances, not all, but most, a lot of the other technologies out there.
I will also say, the EV market is really driving lithium ion and mass production of it, so it's going to be hard to compete with, except for possibly long duration.
Yeah, I was going to say long duration is an interesting place to look at, and I think the challenge there is just, requires the market or the utility to actually value it and value the services that it can bring. So that really is the challenge, less so than necessarily the technology itself.
I think we had a question here.
Hi. First of all, it's been a very interesting conversation. You talked about deployment, you talked about potential impacts of the tax code and what that might have. But one thing here, at least in New York, is we're seeing a growing number of communities, at least a dozen, if not more, outlawing, prohibiting, banning, or just putting a moratorium on battery storage facilities. What impact do you think that's going to have on deployment? How do you reverse that? And what impact is going to have on renewable energy?
Yeah, thanks, Ken. Being that you're under contract with NYSERDA, I thought you were going to throw a softball, but you didn't.
That's the former reporter.
It's a great question, and we're in the thick of it now. As you know, almost all of Nassau County seems to be under moratorium, and they're popping up everywhere. I got 2 emails this morning about, hey, we're meeting with AHJs, what do we say? Right? I think what I'm hearing is the biggest sticking point right now is why would we move forwards until the code recommendations become the code standard, right? And it's a really legitimate question, and there is an answer to that. And so what I've done, I've been so busy within the working group itself, I'm sort of now focusing more on exactly what you're saying. Okay, how do we communicate our findings and what we're doing with the findings? And that's what we're doing starting now. So as I said earlier, May 7th, we're going to have a statewide webinar that's going to explain that you can move forwards now. And that NYSERDA's got your back, right? We're going to do the peer review. We're going to make sure there's an emergency response plan. We're going to make sure you're training first responders. And we have really enhanced our field inspections. So we're going to inspect every single project moving forwards. So just to feel like the local authorities having just jurisdiction, I get it. They just don't have the know-how to know whether something's safe or not. And there's going to be people that are going to have to make a yes or no decision. And they're going to look at the local fire department, and the local fire departments are not going to agree to it right now. So we have to communicate with not only the code officials, but also the fire departments across the board at every one of these AHJs and get the word out. What are our lessons learned? And just really have an honest conversation about it. We're not hiding anything. We're going to tell you everything we found, and we're going to tell you what we're doing about it to move forwards in the safest manner in the country.
Yeah, I just also add that sort of goes back to a comment I made at the beginning around responsible siting, right? That it's understandable in a lot of these instances why communities are reacting in placing some of these moratoriums, right? That there's some instances of poorly sited projects that are just not in a good place for the community and how they want to grow and how they want to use their space going forward. And so being smart about where we put these on the grid and how we communicate the challenge, the benefits relative to the reality associated with these projects is important, right? So yeah, making sure we can find those spaces and yeah.
That's hard to enforce, though. So
It is.
that's
And it's a sort of a call back to the developers to be smarter.
it is. That's the
upfront,
hard part,
right?
though, right? So I totally agree with you. Like, we have to carefully cite projects now. That maybe is something we work with. There's another board member here at New York Best, more on the developer side.
Yeah.
I think we had a question up front, and then we'll go to the back.
Thanks. Again, thanks for the panel for the representation. Quad Decker here with National Grid. So David, I'd like to follow up on what you just said about engaging with the fire department. And you mentioned that we had a project in upstate New York where we had a lot of resistance from the community. It's actually in partnership with the developer. How do we engage the neighborhoods? How do we engage the community and bring that learning proactively in advance of the project? Because what happened from the experience that we had, it wasn't the fire department or the elected official, it was the neighbors who went and it's like, no way, protested for this. How do we engage with these people?
It's a really good question, and I can't pretend I have all the answers. I will say that there's a lot of things we need to do even prior to the engagement. We need as a state to provide developers and utility companies the information that they need and the communication with the communities before you even engage, right? So I would say, first off, it's a high level, what is the state doing? What is the Fire Safety Working Group doing to make everyone feel like we have a good handle on this moving forwards? We're doing things differently moving forwards than we had in the past, right? One. Two, the siting aspect that we keep talking about. I think it's critical that don't be irresponsible, because if you try to site a project near homes, on a school property, in an area where communities have a concern, that is hurting the entire state, the entire industry by doing so. So there has to be a responsibility of industry and developers, and we could work through New York Best to do that, of a code of standard on how to site. I think that's really critical. And then three, obviously, all the items you know about before. We have a siting team at NYSERDA that does work with the communities and the developer community to help provide materials, to help talk through model laws within the state to help you even before you get there. So I think there's a lot of prep work before you get there that we still have to do. And then once you do get there, I feel like it's working with New York Best to have codes, a standard of behavior that you have when you're dealing with the community.
If I may learn a follow-up.
Yes.
David mentioned the team at NYSERDA actually doing a great job, and I hope that they expand their remit and more people. They are.
We just got 2 more people.
Congratulations. But also, David mentioned that I am on the New York Best Board of Directors, so is David, both on the board of directors. New York Best is having a conference. New York Best is a nonprofit, so we're not making pitch for a sale or anything. It's a New York Best is a nonprofit organization, and they have a meeting in May coming up, and part of that meeting is about community engagement, is about safety. So I would encourage all of you to attend if you have the time to be there, and we'd be remiss if we don't talk about that conference.
You're a better man than I am for
It's
bringing that
wonderful.
up. Thank you.
Can I also, I'm going to take my ACP hat off for a moment. And actually, so I live in a rural community in Virginia, and my wife is actually on our local planning commission. And so I think it's important to also look at it from the perspective of these people that are actually doing the permitting and the recommendations as well. And, she is in a volunteer capacity. She, has a day job. She deals with a husband who decides to take day trips up to New York on soccer practice nights. So there's not actually a lot of Virginia is not New York. I think New York's doing a great job in terms of leading on a lot of this, a lot of the codes and practices. But oftentimes, she's looking at real estate developments, she's looking at these community issues. She doesn't have a lot of time to go out and seek, hey, here's the model law or model permits for energy storage or renewable energy. Here's what the latest and greatest about safety is. I think it is really incumbent on the industry, on developers, the moment they start to step into that community, to really be part of that community, to talk to the neighbors, not just the landowner, to work with the community organizations to help them understand the benefits that system's going to provide, and then of course educate the permitting and the agencies that they're going to work on it locally, right? If the first time they're seeing it is just in that monthly meeting where they're running through a huge docket of things, it's going to be, there are going to be more questions, going to be more antagonistic than it has to be.
Wonderful. I think back there.
So you spoke about the importance of AI playing in energy storage and the benefits that it can provide and sort of detecting, these issues. But obviously, with all the data being crunched, there theoretically would have to be a lot of computing power because AI isn't sort of free. So is there ever a concern that the cost of AI in managing the millions of data points from storage could somehow offset the benefits of AI in those storage systems, knowing that theoretically it compounds on itself? Because the more storage, then you need more AI, the more AI, you then need more storage, and then, so I don't know if that's been any thought relative to, because no doubt the things you've talked about of the benefits seem obvious, but I don't know how much those costs have been considered.
Yeah, so I would say that the scale of data we're talking about here relative to when you think about AI writ large or a data center development is very small. That the actual use of energy from the BMS, the EMS, and then the other auxiliary uses around a battery site to actually keep the battery running. So we have HVAC, lighting, heating, cooling, HVAC. It's very small relative to the overall megawatt capacity of most of these systems. So not really of large concern here from our perspective, but it's an appropriate flag, right? And as we think about where do these batteries play in the broader sort of transition and change towards a large load growth associated with data centers, we want to be responsible in what projects and what load we're supporting bringing online.
I think there was a question in the back that was first, and then we'll bounce around.
I want to add on to what he was saying, because I was going to ask a similar question, right? The use of AI is going to kind of bite us in the future, especially because of the compute power. However, there are ways to mitigate that by using things like edge computing, where you're actually adding the AI use not just at the data center level or at a management level, but at every device. Therefore, you don't have to use companies to analyze the data after the fact. The data is going to be analyzed as you start building upon these systems, right? I do think, however, that making sure that these systems are getting back into the grid, not just in data analysis, but in being power efficient and data efficient, is how we're going to be able to implement these AI systems to be net zero, right? Net data zero.
Sorry, was there a question?
Have you guys heard about ideas like these or mitigating the use of AI?
Yeah. It's a sort of related point. Round trip efficiency of the system is tantamount, right? And it drives the overall economics of the battery, and so it is absolutely an area of focus that drives any selection of what EMS, BMS system we're going to deploy.
I think there. Yeah.
This is a really great conversation. Lloyd Cass, Franklin Energy. Question. I mean, there's been a lot of discussion, understandably, about safety and about community engagement and acceptance and all that stuff. But still, at a broader level, we all know, I think, when you compare us to other developed nations in the United States of America, whether it's New York or elsewhere, whether it's building housing, or building bridges or rails, or building any kind of project, the cost of construction is extremely, high per whatever unit. And what would any of you suggest in terms of the kind of transformation either the construction industry, engineering and construction industry, or the regulation thereof. What do you think needs to change while still addressing these safety and community issues?
I mean, I'll just touch on that slightly, which is, I mean, Tesla's doing that right now. They're building the Megapack in a factory and just basically delivering it to the site. The developer can't even open it, right? So I think it's like a prefab house, you know? So, but yes, I mean, New York is very expensive to do anything in, right? So I certainly can't control that. But I would assume that the industry, as it standardizes, will get more economical to be able to do so. It won't mean like New York's going to be cheaper than Virginia, but I think the industry in standardizing prefab sort of development could help.
I think if you look to the solar industry, it's sort of an interesting parallel, right? That where we are today on solar, the cost of the panel is not what drives most of the economics and most of the total capex. We're now at a place where we have 20 cent a watt panels, and in a overall, $1, $1.50 a watt system, it's the cost of the installation and the construction. Solar is doing some interesting things around how do you out in the field use machinery to improve installation. As we look at the battery industry, so yeah, we're taking more prefab, and so less actual work needs to be done on site with the batteries. But then also just being smart about how do we create repeatable, standardized means of installation, and how do you utilize the appropriate cranes to shift these things around and move them on site and like mount and pad them. That's going to be important as well. But we need to, more work needs to be done there. It's certainly starting to drive a larger portion of the value stack for these systems.
I will say though, like if you compare solar with storage has a much higher capex on the equipment than solar. It's not even close.
Yep.
Solar is much more labor cost than storage. So when you're looking at storage, it's really interconnection and all the soft costs that cost a lot of money, on storage that you can reduce. And then, if you look at Bloomberg NEF, you're seeing lithium ion come down over time. We expect that to continue. So I think it's a good comparison with solar, but it's quite different as well.
Yeah, I think my point was that today EPC costs, construction costs are sort of 20% up to 35, 40% of your system on battery storage. But as the cost of the actual system comes down, you're going to get a larger share of the cost associated with construction.
That's true. Sort of like get closer to solar.
Yeah, we're sort of many years behind, but in the same trajectory.
I think we have one question from the gentleman in the very back. This will be our last one.
Thank you. David Phillips from Catalyst Power. We're a C&I-focused developer and a load-serving entity in New York. Most of this discussion has been around front-of-the-meter resources and siting for larger batteries, but behind-the-meter resources are paramount concern. And I'm just wondering if there's anything going on in the state policy-wise to standardize utility approach to tariffs, demand charge assessment. We're seeing pretty consistent policy from utility to utility, and some of which are actually killing projects before they can get off the ground.
Where are you doing most of your work?
The two projects we're working on right now are at NYSERDA and RG&E, but we have a few downstate as well that we're still questioning how they're going to treat those from the demand charge management perspective.
Yeah, I'm sort of surprised you're having problems in that sense, so I'd be happy to talk to you afterwards to get a little more details on the demand charges you're seeing. I will say that the behind-the-meter storage is a very tough sector. I don't mean to be negative about your career here, but because there's so much work that goes into it, and explaining to the customer about what their savings and their return is going to be is more complicated than just doing like a New York City CDG project where it's all export. You don't have to deal with customers. It's so much easier. And so many people are like, oh, you're doing the same amount of work for a 5 megawatt, 4-hour battery than you are for a 300 kilowatt battery. So it's like, it's somewhat nascent right now in the state, right? So I can't say I'm a total expert at behind the meter deployment because there hasn't been a lot of it yet. But I'd like to hear about the use cases you're talking about.
We would own and operate in every instance. So we actually get the economic benefit from load shifting because we serve load.
Okay.
We get the economic benefit of capacity charge reduction. And then we share in the demand charge reduction to the extent there is any with the customer. But the batteries are now being assessed at demand charge as well. Even if they are a meter, project, but, deploy that at customer site, even in front of the meter, we're still running into the same issue.
All right, yeah, it's good that you figured out the customer side to it and how complicated that could be. Yeah, I'll talk to you afterwards. Thank you.
All right, David, MJ, Sebastian, thank you very much. And Stephen will deliver our closing remarks.
Lauren, thank you.
Wrap us up. I'm Stephen Birkenfeld. I'm on the board of Our Energy Policy. Thank you, Bill, for organizing all this and your team. Liam, thank you for your introductory remarks and your partnership. And Lauren and the rest of the panel, David, MJ, Sebastian. That was terrific. There were at least, 5 or 6 questions, hands up, that we didn't get to. But usually people stick around for a while, so just get online and you'll be able to ask your questions then. Before I conclude, I just want to say I actually live on Long Island. And not only is there this opposition to energy storage projects, but I'm hearing that there now is a proposed ban on s'mores whenever it's a windy day. Some of you may understand that, all right.
I guess.
S'mores is what started the fire, the wildfires on Long Island.
Oh, is that right?
Yeah,
I didn't
someone
even
in
know
their
that. Okay,
backyard at 9 in the morning, which is the strangest part of this, was
That
trying to make
is
s'mores.
really funny. Okay.
So I'm going to steal a line from PBS, which is that if you enjoyed this program and programs like it, we would really appreciate you becoming a partner or an individual member, or at a minimum, having a conversation with Carolyn in the corner or with Bill. These are challenging times. My own view is that the energy transition this year, next year, is at a crossroads. We may go forward with advanced battery technology and hydrogen and all these other solutions, or we may go backwards, quoting from the new Secretary of Energy, back to coal and oil. And if you value a independent, objective source of information and insight, then your support of what we're doing at Our Energy Policy would be greatly appreciated. So again, thank you for the panelists, our moderator.
Nice to meet you.
And again, I'm sure people will stick around for a while, at least till 2 o'clock, to take the questions we didn't get a chance to get to. Thank you all very much.